Hi team, let's talk about file security in Linux. And let's start by defining what is a file in Linux OS. Every operating system since the beginning of computing has had the concept of the file. A file is a chunk of data that contains information such as text or binary data like graphics and audio files. There are many different formats of files for various types of data. To handle these files, an operating system will have a file system. This allows users to structure their data in a way that makes it easier to find their files. This concept is pretty standard across all modern operating systems. Linux, however, inherited the Unix philosophy when everything is a file, including physical devices, the computer screen, and so on. The first type of the file we'll talk about is a regular data file. This type of file can be binary or text. It's saved into a storage device and can be read and written to, given the user has the appropriate permissions. It also has metadata describing the file to let the operating system know what type of file it is, who has access to it, and how big the file is. Also when it was created and so on. Metadata is data that describes our data. In the case of the file, it describes the content of the file. A second type of file is a directory. A directory of a list of the other files and also treated as a file. Network circuits are also files. Linux also has virtual files. These are files that don't really exist anywhere and have no size, but you can still read and write to them. For instance, there is a virtual file called CPU info. When you read from it, it shows you information about your CPU. This file has data in it, but has a size of 0 bytes because the operating system creates the data instantly when it's been read. Linux takes the idea of everything being a file so far that even the output of an application is considered a file that has not been saved yet. Another type of a file is a pipe file. You can think of a pipe file as a physical tube or pipe from one application to another. If one application is writing to the pipe file, then another completely unrelated application can be reading from it. In this way, data is being passed between two programs without needing to be saved on a physical storage device, which means that can be very fast. The idea of everything being a file allows us to view important system information and write data to physical devices with simple tools. It allows us to read block devices and the output of commands using simple text viewers. The concept of everything being a file sets Linux apart from other operating systems and proves to be very powerful. Now let's open our terminal and see how we can get the information about the files. As we covered before, data that describes our data is called metadata. This data is associated with the file. Note that the file will contain its own data. For instance, a photo will contain photo information, plus the operating system associates additional metadata about the file as well. This metadata allows us to know about the attributes of our files. These attributes may include the file name, its size, permissions, ownership, and access time, among other things. The quickest way to get information about the file is by doing a long list of the file. Let's type ls-l space etc / password and hit enter. We see that the output has starts with a hyphen, so this means this is a regular data file. The next 3 characters are the user owner's permission. The possible options are R for the read, W for write, and X for execute. The user owner is the third column from the left. In our case, it's a root user, and it has read and write permissions. The next 3 characters are group owner's permissions. The group owner is the 4th column from the left, and in our case, it's also a root group. And the members of the root group can only read the file. The last group are permissions for others. Others are not an actual group, but rather a way of expressing anyone who is not specified. Others contain anyone who is not the user owner or group owner. Others in this example has only read access. Since I'm logged in as Ubuntu user, the Ubuntu user is not the root user and does not belong to the root group. So my permissions falls under the other definition. So I can only read this file but not write to it. The next character is the number of index nodes or inodes that the file use. An inode stores the metadata about the file, as well as a pointer to the location of the data blocks on the disk. The 5th column is the size of the file in bytes. The 6th, 7th, and the 8th column are the last modified date and time. The 9th column is the name of the file. There is another command that shows you metadata about the file. This is the stat command. Let's type stat /etc/password and hit enter. Let's take a look at the output. Stat shows us the name of the file, the size in bytes, the number of file system blocks, the size of the I/O blocks, which means the size of the bytes of every block, the type of the file, and the device number and the inode number. It also has the last access time as well as the last time the content was modified, and the last time the file attribute or content was modified. For instance, the metadata would update if we change ownership or permission, but the file data is not changed. And lastly, the creation time. This last item came from Unix, and unfortunately it's not supported in Linux, so this is why the birth part is empty. Alright, so this is all for this video. Thank you very much. Bye.